We've now reached the point where we're going to solve trig equations. The objective for this lesson is to be able to solve introductory trig equations, so simpler ones, and to get the idea that there can be multiple solutions to these equations because of the periodic nature or the repetitive nature of these trig functions. So let's start off with some review vocabulary and information. First of all, just a reminder of what coterminal angles are. Coterminal angles are angles that add in or end in the same place. Now, how we figure those out is we add or subtract multiples of 360 degrees if we're in degrees, or multiples of 2 pi if we're in radians. So if we have an angle that rotates around and ends there, we can add an entire another circle, another 360, and end in the same place. Those will have the same trig values on it. A reference angle is the angle formed with the x-axis. This is important for getting multiple ones. So if we're in the second quadrant with an angle, this angle here is your reference angle. So just that little angle there. If we're in the third quadrant, so we rotate around over here, this angle here is your reference angle. That's the angle with the x-axis. And if we rotate all the way over into the fourth quadrant, this angle here is your reference angle. So it's the angle formed with the x-axis. All right, now positive or negative values. You got to know when sine, cosine, and tangent are positive or negative. There's a phrase that we've used. All students take calculus to help us remember which quadrant is which. Now, this is the first quadrant. This is where all of them are positive, all trig functions. In the second quadrant, so we're going this way, sine is positive, so all students, sine is positive in second. In the third quadrant, this one is with the T, is tangent is positive. And if you're wondering about reciprocals, it's for the reciprocals also. And then lastly, for the fourth quadrant, calculus refers to cosine is positive and it's reciprocal. So that's how we remember which one are positive in which quadrants. Now, let's go ahead and look at which quadrants are positive just in a summary table here to help us when we do our problems. So sine is going to be positive. Notice in quadrant 1 and quadrant 2. It's going to be negative in 3 and 4. Cosine, on the other hand, is positive in this first quadrant and in the fourth quadrant. And then it's negative in these other two, 2 and 3. Now, how I remember that for sine and cosine, sine is related to the y value. Y values are positive up above the x-axis, that's these two quadrants, whereas cosine is related to the x value, and x is positive in these two quadrants in 1 and 4. And then lastly, when you put y over x to get tangent, that's going to result in tangent being positive in this quadrant first and then third. And it's going to be negative then in 2 and 4. This will help us when we get our multiple answers for this. So our next steps will be to take this information and then apply it to actual problems where we'll get multiple answers. In fact, we'll list it so you get an infinite number of answers because of the repetitive nature of sine, cosine, and tangent. So let's look at this first problem. What we'll do on this is just to solve for sine, get it by itself. So we're going to add 1 to both sides. And then divide by 2. So we want to know when sine equals 1/2. Well, let's look back then at our, up here at our unit circle. So in our unit circle, sine is the y value. When do you see y values of 1/2? Well, you see that right here at 30 degrees, there's a 1/2 right there for the y value. And then also here at 150, notice that that's 30 degrees with the x-axis. That's a reference angle of 30 degrees. So that's how we tie those two together. So 30 degrees and 150 both give me that. Notice that's going to be in quadrants 1 and 2. We see that for the positive. So we're going to get 30 degrees and 150 degrees. Now to represent this for theta, we not only know that, but also all of our coterminal angles. 30 degrees, if we add 360 onto, you get to 390. That's going to be another answer, okay? So 30 degrees, 390. If you add 360 on again, you're going to get 750, and it keeps going. You could actually subtract values as well, the 360 to get to the other direction. And if we add 360 onto this, 360 added onto this will give me 510 degrees, and then 360 added onto that will be 870 degrees, etc. So notice that we get an infinite number of answers, both positive and negative, because of this. Well, instead of trying to list all of them, what we can do is list it like a formula. We can say that theta is going to equal this 30 degrees plus 360 degrees times, let's just say times k, where k is an integer. So if we just add multiples of, just multiples onto 360, onto this 30, we'll keep getting values. Well, the same thing is we can say it equals the 150 plus multiples of k. So this is how we'll list the answer in order to get that idea that there are an infinite number of solutions. This just tells us how to find it. Now, just a note, I'm doing it in degrees here. If you replace this with 2 pi as my radian values and replace these with pi over 6 and this with 5 pi over 6, then you can do it in radians as well. But I'm going to stay with degrees for right now. All right, let's do this next one. Let's go ahead and divide both sides by 2. And then take the square root of both sides. So we get cosine theta equal to plus or minus the square root of 1 is just 1, and then over square root of 2. Let's rationalize that. So you get plus or minus the square root of 2 over the square root of 4, which is just 2. Let's look back at our unit circle. So these start with just values that are on our unit circle. If you notice here, and I'll do it in red here, when we're looking for, and remember, you're doing cosine, so cosine's the x value. Where does the x value equal positive or negative square root of 2 over 2? This angle. Notice this one is a negative, so this angle. This is a negative here, so this also this angle. And then this one's a positive, this angle. So there's 4 different angles that give us that value that we'll get for this. So 45, so theta will equal 45 degrees. Theta equals 135 degrees. Theta equals 225 degrees. And theta equals 315 degrees. If you look at each of those angles back here on the unit circle, notice each of them have a reference angle of 45 degrees with the x-axis. So that initial value there, if you go to each of those quadrants, and for cosine it's all 4, because we've got positive or negative, then we've got all these values. So if I add 360k onto all of these, I get my answer. Now there is a way to simplify this. So for right now, notice that this is a complete answer. If I keep doing multiples of these, this is a complete answer. There is a simpler answer. So a more advanced answer would be to notice that these are all 90 degrees apart. If you add 90 on, you get each of these. So if you do 45 degrees, the original, plus 90 degrees times k, you would also get all of these answers covered. So this is a little bit more of a nicer look at it, a simpler look at the answer, but this is a complete list of the answers as well. All right, now let's look next at this problem. So we want to go ahead and we're going to subtract 1 from both sides. So we'll have 2 sine of theta is equal to 2. Divide by 2, you get sine of theta equal to 1. Referencing back to our unit circle, the only one that has a y value of 1 is here at 90 degrees. Now why that is interesting is that because of this value, we're only going to get one value in the first rotation. So theta is going to equal 90 degrees, and that's the only one we have to add 360k onto. All right, this last one we have to use a calculator because not all values are on the unit circle. So this one we're going to do one that's not on the unit circle, and then we have to use our reference angles and the chart of where things are positive to come up with the answer. So let's subtract 4 from both sides. Then let's divide by 5. So you get negative 4/5. And now what I'm going to do is I'm going to take the inverse cosine of negative 4/5 to get a value. Remember, this is a function, so you'll only get one value out of it, but then I'll use that with my reference angles to come up with more. So let's go to our calculator now. We're going to do the inverse cosine. So inverse cosine of negative 4 divided by 5. I want to be in degrees, so I'm going to check my degree, my mode here, and change it to degrees. And now when I get that answer, it gives me 143.13. So I'm gonna round that to just 2 decimal places. I have to round somewhere for this one, so 143.13. Now that is my answer in the second quadrant, okay? Now we know that cosine is negative it's negative in the third quadrant. So what we have to do is find our reference angle. So let's go ahead and find our reference angle here. 143 here. This is 143 degrees, 0.13. This angle here will be 180 minus 143.13. So let's take 180 minus 143.13, and I get that reference angle is 36.87. This angle over here now, I want to go, like I said, into the third quadrant for my other answer to cosine being negative. So now I'm going to take 180 and add that 36.87. So I get 180 plus the 36.87, and that will give me my second angle, 216.87. So 216.87, that will be one angle. My other angle will be 143.13, and then I'm gonna add 360 K onto both of these to get the multiples that would allow me to get the answer. So this is a little more of a complex way of finding it, but when you have to use your calculator, you need to use your reference angle to find out what is that reference angle in the other quadrant where sine, cosine, or tangent is either positive or in this case negative to come up with your multiple answers. So what we've done here is we've looked at how we can use when sine, cosine, and tangent are positive or negative, the reference angles, and solve these equations and then add coterminal angles. 360 times a multiple k, which k being is just an integer. If you will add on or subtract a multiple of 360, you'll get those infinite number of answers. And this is how we list it. We list it with this plus 360k idea to get what our final answer is and the multiples of answers that are part of this solution.